Today I'm going to talk about LeetCode question number 21, merge two sorted lists. You are given the head of two sorted linked lists, list 1 and list 2. Merge the two lists in one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So for example here we obviously splice the nodes where this guy say went to this guy went to this guy, and etc. And yeah, basically that. Okay. So you might think it's a bit easy to just look at the heads, compare the heads and then move the pointers around. But yeah, it's a little bit more difficult just because you have to compare, which head is smaller or bigger. Now let's say we choose this head up here, and then this is the new head, okay? And then this head is obviously, smaller than this head, but we can't exactly do this, or else it becomes out of order. So it's actually much easier to create a new node. Whoops. So it's actually much easier to create a new blank node pointer. Okay. And have it, and then traverse through. So this is the head, and then traverse through the list. And with this new node here, have a point, okay, towards new head. And then what we do here is now update this head, and now we compare these heads, okay, and then we find out that this is smaller, so we go here, and this is new head, then we compare these heads, and etc. So it's actually much easier this way. What if the lists are of different size? Okay, what if we have like 1, 2, and then 3, 4, 5. This is going to be none. And that's none to signify the end of the list. So we have our new node pointer here. Okay. So now what we're going to do is, yeah, same thing, just have this guy point here, and then this is the new head, this is the head, and then have this point here, okay, and then actually this is the new head, okay, and yeah, so that kind of takes care of that, okay, and this is going to be O of n time, this is going to be linear time, O of m plus n, where m is the length of the first linked list, n is the length of the second linked list. It's linear time. Okay, so now to code this up, so I'm going to start out with a few edge cases here. So I'm going to check if both of these are none, then return none. Else, if one of these is none, then return the not null one. So if list 1 equals none and list 2 equals none, then return none. If list 1 equals none, return list 2, and if list 2 equals none, return list 1. Okay. And now what I'm going to do is create my initial pointer that's going to point to the current element, and then compare the updated heads. So if our new pointer is pointing here, okay, and our head is here and head is here, it's going to compare them, and then it'll make its next the lesser head, so it'll make its next here. Okay, so what I'm going to do is have new head equal to list node object. Okay, and then I'll have static head is equal to head. Okay, I'm doing this because this new head will go traverse through the array, and the static head will stay put at the very beginning of this newly merged array. So then at the end, what I'll have to do is return static head dot next. So while list 1 does not equal to none, and list 2 does not equal to none. So if list 1 dot val less than or equal to list 2 dot val, what I'm going to do is have new head dot next equal to list 1, and then update the list 1 pointer to the next guy, because this guy is already part of the merged list now. List 1 next, else if that condition is not true, new head dot next equal to list 2, and we traverse list 2 forward and make that next node a candidate for the next iteration in forming this newly merged list. Okay, and then finally what we're going to do is update this new head pointer. Head dot next. So basically we're building our merged linked list here with this new head. So if we had this an example, new head, first would be like its own node, okay, and then after traversing through here, would point to this guy, okay, and then list 1 would now be here, list 2 still remains here, and then now that this points to this guy is part of the merged list now, and now we update list the new head to be here, okay. Now this pointer is going to get updated with either list 2 or this list 1, and then obviously will be this one, and then these are now part of the merged list, and we'll compare this, and so on. Okay, and then return static head dot next. And before we do this, I want to talk about one case here. So we have like 1, 2 as our list 1 and just 5 as our list 2. So if we have our new head here, our new head here, so this guy would point to 1, okay, and then at first these 2 would be up for consideration, and this guy is lesser, so new head would point here, and the new head would become this guy. Now these 2 are up for consideration, and obviously this guy would win, so now new is here, okay. But then unfortunately we reached the end of list 1, and we haven't taken list 2 and merged it as part of this new list now, okay. So what we have to do now is check, is one of them not none? Okay, if they're not none, that means we haven't traversed through that whole list. Okay, so for example, this is list 2, and it wouldn't be none after going through this loop. So that means that we would have to update this pointer to point to this guy over here. Okay, and we have to handle that case. So if list 1 is not equal to none, then new head dot next equal to list 1, okay. And if list 2 is not equal to next or none, then new head dot next is equal to list 2. Okay, only one, if ever, only one of these conditions will be true at a time. Okay, we can't have it where, because how else would we break out of this loop if one of them hasn't become none? Okay, so yeah, this takes care of the case where if they are of different sizes, so that the longer list becomes part of this newly merged list. Okay, now we'll try compiling it. Oh, oops. Okay. Switch. Spelling error. Okay. Let me try the rest of the example test cases. Looks good, and I'll try submitting. Okay. Thanks for watching.